taking square roots in case you just joined us. Here we go. So 3 squared is 9. If I want to unsquare 9, what's the square root of 9? Who did you square? Perfect. All right. So guys, before we continue on, notice there's a lot of numbers that we skipped over. Like I went from the square root of 1 to the square root of 4. We skipped right over the square root of 2 and the square root of 3 because they're not numbers that you can take the square root of and get a whole number back. They're not good guys, if you will. So everybody on your calculator, take the square root of 2. Right above the 7, there's a square root button. So hit square root 2, hit enter. What number did you get? 1.4142, blah, blah. Guys, they're hideous numbers. When you take the square root of a number that you can't, you're going to get an irrational answer. You're going to get a very ugly decimal. Now, guys, that decimal doesn't end at the end. It only ended because your calculator screen ended. It actually goes on forever without ever repeating. These are the ugliest numbers in the world. Numbers that you take the square root of that you can't. So the square root of 2 is a really irrational, ugly number. So we don't want you guys to put that as your answer. I don't want this ugly decimal. I don't want this decimal that you had to round to write down on your paper because then you lose accuracy. So the best answer you can write on your paper is just the square root of 2. Leave it as the square root. But we want to make sure that our square roots are always simplified. All right? Do the same thing. What's the square root of 3? Ask your calculator, what's the square root of 3? I bet you it's not a nice number because it ain't on this list. The square root of 3 is what? 1.73. It's an irrational number. It's an ugly, non-ending, non-repeating decimal. Oh, well, square root of 2 and 3 come up all the time in pre-calc, so I always know that. All right, here we go. So we're looking at the good guys, right? So if 4 squared is 16, what's the square root of 16? 4, right? That means all the numbers in between, the square root of 10, the square root of 11, the square root of 12, 13, 14, 15, they're hideous numbers. They're not perfect squares. All right, square root of 25 is? 5. All right, perfect. So everybody fill in the rest of your list. Get me all the good guys. The square root of 36, the square root of 49. Yep, keep going, Jay. You got it.
9.
Yes.
10.
11.
12.
13. 14. Now, guys, I could literally stand here for the rest of my life and just keep squaring numbers and creating perfect squares. I don't got time for that, and neither do you. So just know they don't stop here. They keep going. I just didn't want to keep listing and listing and listing. All right, so all the problems that we work with today, guys, these are the good guys. These are the numbers you have to imagine. These are the numbers that you can take the square root of and get whole numbers back. I don't want to deal with numbers that I can't take the square root of. We only want the good guys. So I wrote them over here for the most part, just so I'm going to have to move that up. These are the numbers we want to keep in our mind. We usually don't worry about the square root of 1 because he's not going to help us in any of the problems. He doesn't change anyone's value, so we really don't include him. All right, here we go. Let's do it. Let me give you a few properties that we're going to use to simplify a square root, and then we'll get to it. All right, here we go. So let's say you have the square root of A times B. You are allowed to split that product up and put A and B under their own square root. So the square root of A times B is the same as the square root of A times the square root of B. We're allowed to split that up into separate square roots. Now that rule, it works both ways. If I have the square root of A times the square root of B, I can times them together and put them under one square root. It works both ways. Okay. Guys, you might, when you solve a quadratic equation by using square roots, you might have to take the square root of a fraction. So we're going to have to get used to that too. So if you have the square root of A divided by B, you are allowed to split them and put them under their own square root and deal with them one at a time. So you are allowed to think of it as the square root of A divided by the square root of B. Now the only reason we're allowed to do these two rules is because there is no addition or subtraction involved. The minute you bring in adding and subtracting into upper level math, it makes everything harder. It's so deceiving. You learn adding and subtracting in kindergarten as these nice, easy operations. You throw adding and subtracting into higher level math, and man, does it ruin the whole problem. It blows the whole thing up. So the reason we're allowed to do this is because there is no adding and subtracting involved. All right, and then the last one. And guys, this rule works both ways. If you have the square root of A divided by the square root of B, and it's beneficial to write it as the square root of just the fraction, you can do that too. It works both ways. All right, the last one. This is a big one. If I have the square root of A times itself, the square root of A. Guys, what do we call that in math when you times something by itself twice? You're squaring. Exactly. So basically, this is like taking the square root of A and squaring it. You're literally timesing it by itself twice. Well, guys, I hope you realize that squaring something and square rooting it is literally the inverse operation. They're opposite operations. They undo each other. Adding 3 and subtracting 3. Those are inverse operations. They will undo each other. Timesing by 3, dividing by 3. They will undo each other. If you square something and then take its square root, they undo each other. They're opposite operations. So what does a square do to a square root? And you're just left with A. So when you times a radical by itself, you're literally just left with the number underneath. It's actually easier to see with numbers, but I just wanted you guys to know it works for all numbers. Think about it. What if I told you, don't write this down. What's the square root of 5 times the square root of 5? Well, according to this rule, it's the square root of, what's 5 times 5? And who's the square root of 25? 5. So it's literally just 5. So when you times a radical by itself, the radical will go away and you're just left with the number underneath. And that's going to be really helpful because there's going to be problems where we're going to have to get rid of the radical. And if you have to get rid of the radical, times it by itself. Let's do it. We're ready. We are ready. Oh, that should be easy. All right, here we go. So we're going to start really easy. Jake, really easy. And then we'll slide into the harder ones. All right, let's start real simple. If I asked you guys to simplify the square root of 49, guys, who is the square root of 49? It says there are numbers that we can take the square root of. These are the good guys, so don't forget them. Your answer is just 7. Beautiful. All right, but what if I asked you to take this? What if you were solving a problem, a quadratic equation, and you had to take the square root of 12? Guys, can you take the square root of 12 right now and get a whole number? Is he one of our good guys? No, he's somewhere in here, right? The square root of 9 is 3. The square root of 16 is 4. The square root of 12 must be 3 point something. Ask your calculator, who is the square root of 12? Already, I think I know. All right, hold on. That's fine. What do you do? 3.5-ish, but it's a really ugly number, right? It's an irrational number, long, never-ending, non-repeating decimal. All right, so we know it's about, isn't it like 4.6-ish something? 3 point, okay. We don't want that. I do not want you taking the square root of, I don't want you taking the square root of 12 in a math problem and then rounding it to 3.5 or rounding it to 3.46. As the minute you round something in math, your answer is no longer accurate. It probably won't make the equation true. If x was supposed to be, making the equation equal to 5, maybe now it equals 4.999. It will never make the equation true if you round your answer. So we don't want to round. We want to simplify. So since you can't take the square root of 12 and get a whole number back, I want you to look at the numbers that you can take the square root of. Square root of 4, square root of 9, square root of 16, 25. Find me a number, the biggest number on this list that divides evenly into 12. Who's the biggest number that you can take a square root of that divides into 12? 4. So we're going to factor this. We're going to split it up. We're going to rewrite this as the square root of 4 times the square root of who's left over? 4 times what gets you 12? 3. And now what is the square root of 4? 2. That's a number we can take the square root of. So his radical is gone, and now it's going to be the square root of 3. Can you take the square root of 3? No. Do any of these numbers divide evenly into 3? So he is a simplified square root, and we leave it as 2 times the square root of 3. And that is your simplified answer. Now, guys, who did we say the square root of 12 was? 3.46? Ask your calculator, what is 2 times square root 3? 2 times square root 3, hit enter, what does it tell you? The same thing, 3.46, whatever. Because it is the same answer, except this one is simplified. So you're going to have to do next. So your calculator is fancy. It's the 36 Pro. I have it too. It's wonderful. It's polynomial equation solve. You literally, what you have to do is it automatically leads your answer as a reduced radical. Yeah, so if you take the square root of 12, see it up there in blue? You have to hit second and then that button. This gets you to the blue keys. Yep, and then you hit that. Yeah,
Sorry, can I do one on the
All right, here we go.
Can I do one on the board?
Man, hold on. Let's take my fun away, Jake. It's my favorite game. Hold on, we'll see. Maybe I know which one you can do. You can do one. All right, here we go. So now that's what you want. They are the same answer. Guys, this would be like your fraction is 4/8, and then your reduced answer is 1/2. It's the same answer. This is just reduced. You don't want to leave any of your perfect squares inside that number. Let's do another one. What if I asked you to take the square root of 45? We're solving, and we got to take the square root of 45. First of all, is 45 a number that you can take a square root of? No, he's somewhere in between the square root of 36 and the square root of 49. So he's 6 point something, right? We don't want decimals. So now what you want to do is you want to try to simplify him. Find me the biggest number on this list, the biggest, that divides evenly into 45. 9. So we're going to split him up into the square root of 9 times the square root of who? Who's the leftover? 5. And now, that's why we picked 9, because we can take his square root. What's the square root of 9? 3. And then the square root of 5 stays. And how do we know the square root of 5 stays? Number 1, you can't take his square root and get a whole number. And then are there any numbers on this list that divide into 5? No. So one doesn't count. That's why I crossed him out. So he is a simplified square root, and he's the one that's allowed to stay. Go ahead, Darren.
Why did you pick 5?
I didn't pick 5. I picked 9. Because 9 is the biggest number that I can take a square root of that divides into 45.
Why did you drop the 5 down from the...
No, I did it because 9 times 5 gets me 45. Yeah. So you pick your perfect square, and then you have to figure out what times him gets you that number. Yeah. Now, every year somebody does this. Well, Hardy, I did 15. And they're like, okay, I'm not saying that that's wrong, but did it get you anywhere? Can you take the square root of 15? Nope. Can you take the square root of 3? No. So you want to pick a number that you can take a square root of. Now, there is a way to do it this way, but you have to make a prime factorization tree. And I don't know if you guys want to get into that. To me, just pick the biggest one and go with the biggest, and it gets you to the answer the quickest way. All right, let's do it again. How about, I get you. All right, I want you to take the square root of 48. You're going to do the next one, Jake.
Right.
So first I asked myself, can I take the square root of 48? No, he's somewhere between 36 and 49. So again, he's 6 point something. So your job is to find the biggest number on this list, if there is one, that divides evenly into 48. So guys, what I do is 49 is too big, right? So I start with the next one. Take 48 divided by 36. It's a decimal, so it's not him. Take 48 divided by 25. It's a decimal, so it's not that. Take 48 and divide it by 16, and what do you get? He's our guy. So I like to start at the highest one possible and work my way down the list. Because if you work your way down it, the first number you come to that works will be the biggest one. If you go this way down the list, 4 works. But there's a bigger one, and I don't know if you'll get to him. So I think you should work your way from the biggest number down to the smaller numbers. All right, so we're going to break him up into the square root of 16 times the square root of who? Who's left over? 16 times what gets you 48? 3. Who is the square root of 16? That's why we chose him, because we can take his square root away. So it's 4, and then the square root of 3. Can you take the square root of 3?
No.
No? Does he simplify? Any of these numbers divide into 3? No. So he's your leftover, and that's your simplified answer. It's going to get nice, because it gets into a rhythm. All right, now, was anybody thinking, well, Hardy, I picked 8. For whatever reason, I cannot get students to forget that 8 is not a perfect square. Guys, 8 is not a number that you can take a square root of. He's my favorite number. He's the best number in the entire world. But you can't take his square root, so that really wouldn't help. Did anybody think it was 4?
No. Low rate.
Okay, so let me just show you this. Don't write this down. But guys, if you said it was 4, you could break it up into the square root of 4 times the square root of who gets you 48?
8.
4 times 2 gets you 48.
Oh, wait.
12, okay?
Sorry.
Then you would go, who's the square root of 4?
2.
2, and then the square root of 12. Why would you get marked wrong for that?
Because you can still
Because
simplify.
12, you can still simplify 12. 12 is not a simplified square root. So you'd either have to go back to the beginning and start over, or you can just keep going. 2 is waiting to be multiplied with whoever breaks himself free. Now just simplify 12. Who's the biggest number on that list that divides evenly into 12? So you break it up into the square root of 4 times the square root of who? 3. And now 2 times who is the square root of 4? 2, so he's free. And then the square root of 3 is simplified. And at the end of the day, who's 2 times 2 on the outside? 4 root 3. So you do get the same answer. Man, you worked a hell of a lot harder than this guy, but it still works. Just keep reducing. But if you pick the biggest perfect square, then you'll only have to do it once and be done. Okay? All right, Jake, you're up. Everybody, simplify this.
Thank you.
Simplify the square root of 75.
All right.
If you get out of the way of the perfect square.
This used to be you, Brendan. All right? Okay.
Hug buff.
2 days.
I know. Well, this is the first day of this, so that's good.
Yeah.
So you take 75, right? You look at it. It's just not on his list. Can't do anything about it. Oh well. Right?
Not oh well, Jake. Never oh well.
Oh well.
Okay.
So you look here, 64, 81, 75.
Oh, why do we have to do this? So stupid. Oh, God.
You look at 75 between that.
Oh, Darren, this is so annoying. Oh, my God.
Out of the class.
Does it sound like you, Jake?
Oh yeah, and then I'll throw a marker at you with
Shut
the
up, I
same
know.
shirt like
Okay,
you
stop.
did.
Do it. Okay.
So
Did it come out? Get the same thing?
you're confused.
It didn't. I will pay you. I will Venmo you. Okay.
Keep on McDonald's.
Sorry, Jake. Go ahead.
Yeah, that was very inappropriate,
What are
but
you gonna pick it up?
what?
What are you gonna pick up?
All right, so you look at 75, right? We got that part, so it's drawn.
Oh, he's stalling. He's stalling.
25.
Oh, listen to the man.
That's the class.
What's the biggest?
All right, guys. So we're gonna go down. We're gonna look what back
What divides evenly into
divides
75?
100. No.
24.
Don't listen to him, Jake. You know it. What number is it?
Someone else is supposed to say, it, not the teacher.
Wow.
Anyways, it's 25. Thanks.
It's not easy being a teacher, Jake.
After that, you guys are gonna put the 25 in this little box looking thing.
The square root.
Get that 25 going.
You gotta show the camera
Yeah, you
too.
gotta show the
Oh yeah, we're recording, Jake.
75, 25. After the 25, you're like, how do I get 25 from 75? How do I do that?
You multiply it by.
Division.
Help him out. He's doing great.
Where's the
So you get to 25.
Okay.
3. You cannot find the square root of a 3. It's illegal. There is none.
25.
So you take that, right? 25.
Five.
There you go. You're saying it. There you go.
Bring on the answers. Can I get some hands going, showing up? Yeah, you in the front. 5. No, that would be correct, but I don't know how.
And then do the square root of 3 next to it. Other side. No, other side. Bring
All
the
right,
square root.
everyone. Teacher needs a second. Had a little bit too much to drink on lunch break.
Wow. Bro.
There you go.
5.
5.
Okay.
Okay.
I mean, he said he was drinking.
Now, what do you think we could put here? Because we can't get this. We cannot get the square root of this. So we gotta put it here. Let's all say it together. In 3, 2, 1.
Great.
3. Good job. I'm so
Jake,
appreciative.
that actually was real good. I think they missed me. Jake, that was very good.
Can I have a thank you?
Very good, Jake. Perfect. All right, excellent, Jake. I really appreciate that. Thank you. All right, now The only thing I want you guys to watch out for is I don't want you to force anything either. So sometimes you may have to take, let's say you have to take the square root of 10. And a lot of people just mistake, oh, 10, he's even. It's a beautiful number. I can definitely take his square root. I can definitely simplify that. Guys, can you take the square root of 10?
No.
No, look, we skipped right over him. Can you do any of these numbers divide evenly into 10? So the square root of 10 is done. You would leave it as the square root of 10. He's already simplified. Go ahead, Chris.
So I know I said 25. How do we get to 5?
Because the square root of 25 is 5. We picked 25 because he's a number that divides evenly into 75, whose square root we can take. You're trying to find numbers whose square root you can take.
Oh, it's just not good.
Remember?
Right.
Oh.
Yeah, what's up?
Remember when you were about to throw hands with that kid? You said you had.
Oh, the one who I called the bad name?
Yeah.
Yeah.
I'm really upset.
No, you're not. Chris is nothing compared to that kid. Nothing.
Oh, you hear that? You're a nothing.
No, I didn't say that.
You're a nothing.
All right, Jake.
Nothing.
All right, so now, same thing. Sometimes they ask you, what if you have to take the square root of 79? Some students
Listen up.
think that it's so big, but oh, this has to simplify. Give it quick. So it's the square root of 79. Guys, nothing on this list divides evenly into 79. So that, believe it or not, is a simplified square root. So don't worry just because it's a bigger number that you're going to be like, oh, it has to simplify. No, if a perfect square doesn't divide evenly into it, it's already simplified. Okay? Go ahead, Chris.
Just to clear my name,
Yes.
it was a justified being on the
Listen, I didn't hear all the details, Chris, but we're recording.
I'm
We're
sure
going to talk about it. Because I would love to talk to you, because Spidey doesn't solve anything.
Chris is a wussy.
No, stop it!
No, I hate.
Listen, we all saw the video.
Chris is a wussy.
Jake, Jake.
I thought Jake in the middle of softball field and I broke his nose.
Chris is a wussy.
So don't even.
Done, you're making me sweat. Like, stop it. All right, here we go.
Weaver is a wussy.
All right. Chris, go on.
I broke his nose.
I believe it. I'll ask you.
Still a wussy.
So now we have to do division. And I'm not going to lie, division is just, I feel like, always harder than the multiplying, whether it's with numbers or radicals. So we're going to start off pretty simple, and then I'm just going to lead into maybe a more difficult scenario. I'm trying to think of anything that could come up when we start solving using these square roots. So let's start easy. Oh, what number am I on? 7. All right, so let's say I had to ask the square root 8.
Oh my.
The square root of 18 divided by the square root of 2. So in math, you kind of want to always try to look into the future a little bit. Look at this one. If you have the square root of 18 divided by the square root of 2, naturally, you're supposed to look at it individually. Look at the square root of 18, see if you can do anything with that. Look at the square root of 2, see if you can do anything with that, and then we'll work from there. But guys, at the end of the day, we do have this rule. I'm allowed to go this way and split them, or I'm allowed to take 2 separate and put them back together as one square root. Guys, what's 18 divided by 2? Is that a really nice number to have under a square root?
Yeah.
Oh my God. So I think if you can see that, then I would definitely do that. Make it the square root of 18 divided by 2, which is now the square root of 9. Who's the square root of 9? 3. So your answer is 3 and you're done. However, if you didn't recognize that, this is how you handle it. Or let's say it didn't divide to a nice number. Then you're going to have to just handle it one square root at a time. So first I want you to look at the numerator, the square root of 18. Can you take the square root of 18 and get a whole number? No. But can you simplify it? Is there a biggest number on this list that divides evenly into 18? 9. So we would rewrite this as the square root of 9 times the square root of who's left over? 2. And then it's divided. Now look at the square root of 2. Can you take the square root of 2? No. Does he simplify? Any of these numbers divide into 2? No. So he's already simplified, so he gets to stay. So then it becomes, who's the square root of 9? Times the square root of 2 stays, divided by the square root of 2. Now guys, you're always looking to simplify anything you can. This is only multiplication and division. There's no adding or subtracting. So PEMDAS says I can do M or D. So if I divided first, what does a root 2 and a root 2 divide to? They cancel and you're just left with 3. So you'll get the same answer, but you clearly are working harder for this way. So if you recognize nice division, you might want to do that first. This doesn't pop up all too often, but we should always be looking for it. All right, now, this is what we're going to really have to get into. All right, what if they asked you, you're solving, and you have to take the square root of 1/4. If you have to take the square root of 1/4, well, guys, I'm looking at the fraction. 1 doesn't divide by 4. It doesn't simplify to a different fraction. I'm kind of stuck. However, are 1 and 4 nice numbers to have under a square root? Yeah. So let's split it. Let's put each of these under their own square root. Let's take this and split it, and let's deal with one square root at a time. So let's rewrite this as the square root of 1 divided by the square root of 4. Okay, guys, who's the square root of 1? 1. Who's the square root of 4? Done. It's 1/2. So if they gift you perfect squares, oh, it's the best. It's the best because these are numbers you can take the square root of. All right, what about this one? What if you had to take the square root of 13/4? Well, I'm looking at it. 13 doesn't divide by 4. Don't reduce to a smaller fraction. Not that I really wanted to because I'm really liking the 4. So since I'm not getting anywhere right now, let's split it. Let's give everything its own square root and deal with it one square root at a time. So it's going to be the square root of 13 divided by the square root of 4. Let's look at the square root of 13. Can you take the square root of 13? No. Does he simplify?
No.
Great. Let's work for us. He stays. What is the square root of 4? Done. So now you're left with the square root of 13 divided by 2. That is the most exact, simplified answer you could give for that radical. Now, guys, math is mean. I'm not going to lie. Math can be very, very mean. It's got all these little unwritten rules, right? There's a rule that says you are allowed to leave the square root in the numerator. Remember, the square root of 13, guys, it's an irrational number. It's a very ugly decimal. So you're allowed to leave an irrational number in your numerator. You are not allowed to leave an irrational number in your denominator as the divisor. So if a radical is left in the denominator, we have to get rid of it. We're not allowed to leave it there. So let me show you one like that. And then, oh, 5 minutes, we're okay. All right, look at this one. All right, what about the square root of 3/5? Right, let's say you got to the end of the problem, you had to solve for x, you took the square root, you have to take the square root of 3/5. Well, I'm not getting anywhere right now. I can't take 3 and divide it by 5. They don't reduce to a smaller fraction, so let's split it. We're not getting anywhere. So let's rewrite this, as the square root of 3 divided by the square root of 5. And we'll deal with one square root at a time. Okay, can you take the square root of 3?
No.
Did he simplify?
No.
Beautiful. Can you take the square root of 5?
No.
Does he simplify? No. Okay, so you think you're done, right? Unfortunately, math says no. They say the square root of 5 is an ugly number. It is an irrational, never-ending, non-repeating decimal. You are not allowed to leave it in your denominator as the divisor. So you have to do something that says you have to rationalize the denominator. Right now, you have an irrational denominator, and we need a rational denominator. Okay, kind of, what did we learn that you can times a square root by that will make his square root go away? Itself. So whatever that denominator is, we're going to times it by itself. So we're going to times the bottom of this fraction by the square root of 5. Times that radical by himself. Now, guys, math also has a rule that says whatever you do to the bottom of a fraction, you have to do to the tops. Now we have to times the top by the square root of 5. All right, now what do we got? Well, guys, the square root of 3 times the square root of 5 is just multiply them together and put it under one square root. So what's 3 times 5? And you put it under a square root. So it's the square root of 15. Their square root doesn't go away because you didn't times the same radical by itself. All right, that's now over. Who's the square root of 5 times the square root of 5? It's the square root of 25, which is just 5. So now you don't have a radical in your denominator anymore. All right, now, the only thing you have to check to say before you're done is now you got to look back at your new radical on top and ask yourself if he simplified. Can you take the square root of 15?
No.
Does he simplify?
No.
Then you're done. And math says you can leave your answer like that. So again, technically this and this are like finished problems. They're just not in a form that you're allowed to leave it in, okay?
Can I do this wrong?